Hi, my name is Karim Muci. I am a professor in the Ingram School of Engineering of Texas State University, and I'm also the academic program coordinator for the mechanical engineering program. Mechanical engineering is a very exciting field. It's one of the oldest and broadest engineering disciplines. Just to give a general idea, when you look at mechanical engineering, we're dealing with components that involve, or products or systems that involve parts in motion, or the flow of a fluid, or basically the generation, conversion, and transfer of energy. To be a mechanical engineer, we have to be very good in math and the basic sciences like physics, but we also learn additional knowledge that we need to design products or systems. For example, we start learning about fields called solid mechanics, thermofluid sciences, dynamics, measurements and controls, among others, so that we can conceive, design, implement, operate, and retire from service, different products and systems. Mechanical engineers participate in the development of a extremely wide variety of products and systems. For example, we can be involved in the design of domestic appliances like a washer, dryer, or a refrigerator. We can also be involved in renewable energy systems like creating a wind turbine that we can use to capture and harness the energy of the wind. In the case of medical devices, mechanical engineers can be involved in the design of prosthetic devices, and also in things more sophisticated like a temporary artificial heart that could keep people that have problems with their heart alive for a longer period of time. Other applications, if you look at our soldiers, in the military, we design protective equipment for them, including the vest that you see that they wear, because we want to make sure that they are protected. And the list goes on, even if you take a look at your cell phone and other electronic components that can be subjected to impact. The mechanical engineer has to be there to make sure that they can withstand those particular loading scenarios. When we graduate as a mechanical engineer, we have different options. Sometimes we work in a design capacity, sometimes we may be working in maintenance, operation, manufacturing, technical sales. In some cases, like in mine, we decide to go to grad school and learn a little bit more and work on more of scientific research. Nowadays, there are many new technologies that are emerging that are being used to develop new products, manufacturing systems, and even that are changing the way we as engineers design those products and systems. Just to name a few, industry right now is getting a lot of attention. They're giving a lot of attention to things such as 3D printing and additive manufacturing. We have also technologies such as advanced computer simulations and digital twins, where we try to mimic in the virtual world what happens in the real world. We also have robotics and automation, artificial intelligence, cybersecurity. There are many of those technologies, big data and data analytics, that we as engineers will be exposed very soon when we are out there. One of the things that make the mechanical engineering program at Texas State unique is that besides a traditional mechanical engineering education, we are going to augment it with courses and learning experiences where students will be able to gain a basic understanding of all those new tools and technologies. We'll be able to get familiar with them. Not only that, we're going to do it in a context of product design and development. So we're going to talk with our students throughout the 4 years of their education here in different classes about the process that is followed to design and develop new products. Our faculty, since we are a new program, is fully committed with those two goals, incorporating these new technologies that are out there and tools together with this context of product design and development.